So, Christos, welcome to the channel. Make cancer metabolic, not genetic.
Thank you. Nice to be here.
Thank you. So how did you get involved with Professor Seyfried?
Well, he sent me an email some years ago and regarding my biochemical aspect on cancer, and he was spot on. And that's what I replied to him. And ever since we started emailing, then I visited him several times. I think I have, yes, given a lecture in his university once, and he was also invited here as well in a major bioenergetic meeting. And we have published several papers together. It's a very strong and active collaboration. He's a very active person despite his age.
Yeah, absolutely, absolutely. He amazes me. I mean, he was on a podcast the other day with Stephen Bartlett, who is a guy here in the UK who is on a program called Dragon's Den, and Stephen Bartlett has 7 million subscribers to his podcast. So
Wow.
yeah, so the message is really starting to get out there. So what's your view regarding the metabolic part of cancer?
So, in my view, is that I do not know if cancer is a metabolic disease or a genetic disease. I lean a bit towards, of course, metabolic disease, but my definitely point of view is that it can be addressed from the metabolic aspect, meaning the tumor metabolism exhibit very different properties than normal tissue metabolism. And that generates an Achilles heel for it. So it is possible to treat cancer by identifying the differences in metabolism in the tumor versus the healthy tissue, and then directing any kind of effort, drug, genetic, whatever, to prevent cancer cell proliferation. That's my very firm aspect about this. I'm very convinced that addressing the tumor from a metabolic point of view, perhaps not the only way, but definitely should be included in any future regimes in combating this disease.
Yeah, absolutely. So what do you think? What's the current state of the art regarding the metabolic part of cancer?
So the the current state of the art is that it starts to pick up. There are people, high profile, let's say scientists, who are interested in the addressing the metabolic aspect of cancer, and not just from the scientific point of view, but also from the pharmaceutical point of view and from the clinical trial point of view, so that there are more clinical trials and drugs directed towards addressing the metabolic aspect of cancer. So I'm glad that this thing has turned, because for several decades it was very much focused exclusively on the genetic aspect of cancer, which was unfortunately wrong. So hopefully the tables will turn, and within the next few years or decades, we are going to see major breakthroughs coming from addressing the tumors from the metabolic point of view. But it will face, I think, enormous opposition from a huge cartel of pharmaceuticals companies that they market their drugs, which are directed against genetic manifestations of cancer, which I think it's not good.
No, exactly. I actually believe that it will come from the ground up, and that behind me there is it's a disruption curve, and
Okay.
that's how things like EVs, like the iPhone disrupted Nokia, like the car disrupted the horse, like colour television disrupted black and white, etc. And I think, from a personal perspective, that it'll come as a disruption from the bottom up. People will get better doing metabolic therapies, and they will seek out the information on the web, like this and all of the podcasts that have been in that instance, because it won't come from the top down, because there's no money in it, is there?
Yes, yes, and hopefully, yes, we will going to see this within our lifetime and very soon. The only problem, but I don't think it's an impediment, is that it requires a very good understanding of basic biochemistry, and people are a little bit frivolous about this. So they consider metabolism as a very well understood and known thing, and they kind of ignore the detailed but very important rewirings that can happen within tumor metabolism. So even though I'm saying that that tumors will address metabolism address it from the metabolic point of view, unfortunately, many of them will use traditional metabolic schemes that do not really apply on tumors.
Yeah.
This is something. This is going to be a learning curve, and it will cost a little bit more time and money until people will realize what exactly is happening. But we will get there.
Yeah, yeah. So what's your lab working on currently?
So we are obviously interested on cancer metabolism, and just to be a little bit more specific, we are very much interested in the glutaminolysis pathway. So it has been known for many decades that cancer cells require on provision of glutamine for growth and metastatic potential. And this is also something that contributes to the cancer cachexia in people who suffer from cancer. So one of the many reasons for cancer cachexia is because tumors divert glutamine in the body towards the tumor. Now, the glutaminolysis pathway is something that can occur in the absence of oxygen, and this is very crucial to the tumors because solid tumors, they can grow so fast, there is not enough time for the vessels to penetrate in the interior of the tumor, and they still thrive using so-called hypoxia biology. We're not going to go into the details of that, but within the realm of hypoxia biology, they are able to catabolize glutamine in their favor for growing and metastasizing. So we believe, and actually this is more of a belief, that's what we see in our in vitro models, that and not just us, but others as well, including the Seyfried lab, that if you block the glutaminolysis pathway, this is detrimental for tumors. They are not able to withstand the inability to use glutamine. So this is what we are after. And within the glutaminolysis pathway, we have a couple of good targets. So we are trying to revive one drug that has been used in the past to inhibit glutaminolysis, and that may sound a little bit awkward, but it is arsenate. Arsenate is something that has been used in the past to treat conditions, and it's still used today for treating so-called blood cancers. And so we're trying to revive this channel. And the other one is that we are trying to design drugs that inhibit targets a little bit more downstream than what arsenate is inhibiting. And because arsenate has many side toxic effects, I mean, arsenate is number one poison in the world because of but you know, as Paracelsus said, the poison is in the dose. So anything can be poison if given in sufficient amounts.
Yes.
So it is possible that if you can use arsenate and in particular formulations and in small amounts, then it can be detrimental for tumor formation. So far, the problem with arsenate in the past decades has been found not in the toxicity, but in the very high clearance from the body. So if you want to address a solid tumor and you give arsenate to a person, it's going to go everywhere very fast, and then it cleared up by the kidney very fast. So there is not enough time to concentrate it in the tumor. So many efforts are now in addressing how can you direct arsenate to go just to the tumor and not to the rest of the body, and not to be cleared that fast. That is one of our goals.
Right. That's incredible, because when you first started there, I was expecting you to say 6-diazo 5-L-noreleucine, Don, when you were talking about targeting the glutaminolysis pathway.
So the problem with DON, I mean, DON is a glutaminase inhibitor. So, but the problem is that tumors have many ways for providing glutamate, which comes from glutamine, bypassing the glutaminase step. So with DON, you do expect to have some, decrease in glutamine provision to the tumor, but it cannot be complete because tumors are able to recycle some of their other amino acids to get glutamate without the use of glutamine. If you inhibit glutaminase, you actually induce the tumor to do that, to induce the bypass pathways. So glutaminase inhibition with DON, for example, is not going to be sufficient. You need something else as well. Besides, of course, diminishing the glucose provision. That's another story. But let's just stay now on glutaminolysis. So glutaminase inhibition is very upstream on the glutaminolysis pathway. And if you inhibit that, tumors will be able to find ways to bypass this and continue the pathway downstream.
Right. Okay. A friend of mine, he's become a friend, Jason Watson. He interviewed Professor Seyfried. He's suffering with a particular form of esophageal cancer, and he has done the whole press pulse protocol himself, and he's getting tumor progression, and of course he's really upset about that. And he's looking at alternatives back to the standard of care, which is a real shame to see, such a warrior suffering,
Yes. So with the standard of care, there aren't any alternatives, unfortunately, and it won't be within the next year or even within the next 2, 3, 4, 5 years. It's very unfortunate. So when you want to create the rupture, as you mentioned, especially on something so well established like the standard of care, it has to be verified on literally hundreds of thousands of people. Even if you find one or two that will respond to, I don't know, press pulse or whatever, that will not be enough. That will not be sufficient to change the standard of care. This has to be done state-funded and international, and it has to change the general idea in order people to start considering ever to deviate from the standard of care. Otherwise, it wouldn't be called standard of care.
Yeah. No, absolutely. But as the Professor Seyfried says, it shouldn't be written in granite.
That's true. That's true. Well, yeah. So I remember one thing that could help would be rather quite a sad event. If you remember, Alzheimer's disease in the United States, it was kind of, not so well funded. But after Ronald Reagan developed Alzheimer's disease, it was a huge increase in the AD funding. So unless you have some sad events that some very important people will get cancer, and they will start diverting money towards alternative treatments and against the standard of care, it's not going to be. It's going to be difficult to change it. So it would accelerate it because it will change, that's for sure. But these will be so-called accelerating events.
Yeah, no, I get that. And if Elon Musk's mother was to get cancer, for example, then I'm sure. And given that Elon is such a think outside of the box sort of a guy, then I'm sure he would look into go back to first principles, as they say. As long as he didn't just do what President Biden's son did, which was go to Dana-Farber or whoever and get the so-called best standard of care, which obviously the best standard of care killed him within a week or 2 weeks or whatever it was. Yeah. So do you think cancer could be beaten? And what role do you think pharma has to play?
Well, okay, that's two different questions. So cancer, yes, will be beaten. It can be beaten. It can be beaten because we see differences in tumor metabolism versus normal tissue metabolism. So as long as there are differences, that means these are vulnerabilities. You just have to find a way to address only those vulnerabilities and not the nearby healthy tissue. So this is just a matter of time. Now, remember, pharma is there to make money. Okay, it's not.
Yep.
It's not to. I mean, the improvement of the client's health is a side effect, is a beneficial byproduct. And the best thing for pharmacists is to keep the patient in limbo, because that could keep them as client. If you had no ill people, there wouldn't be any money making by the pharma. Now I'm telling it very simplistically, of course, but this is the concept. Okay, so if pharma will see an opportunity in making money by people becoming better, but not preventing cancer, yes, they're going to jump into this. But remember, they already come from a money-making scheme, which are the existing chemotherapies and radiotherapies, and they cost a lot. And so for as long as they make money from something, they're not going to deviate from it unless they go into something that makes them more money.
Yeah. That's the really scary thing. The fact that it's all about the money. And I put out a video on my channel a while ago, and Ray Piana, and it's just
Yes, I'm aware of that video. Yes.
Yeah. Now, a guy on the that came on the channel, a citizen scientist by the name of Mark Litton, has written a book, and he proposes a different theory of cancer, and that the mitochondrial metabolic theory is correct. Basically, what he says is that it's fungal pathogens that actually cause the cell to go into the fermentation state in the first place. Have you any thoughts on that? Have you heard that before?
No, I have not heard about it before. Okay, so about the fungal pathogens, if there was a fungal pathogens involved, there would have been, it's easy to detect, because fungal pathogens, they express proteins or even metabolites which are very different than the human, and they would come up. Well, if I haven't seen them, it's not because they're not there, it's because I'm not going after them. But it would be very easy for me and for anyone who works in my field to identify fungal pathogens. Now, the fermentation thing, the human tissues, when they are growing up very fast in a physiologic manner, like for example stem cells or embryos, they do exhibit fermentation. So this is a normal thing. So the fermentation is not to be blamed as such, but is to be blamed when it happens in, let's say, in the wrong context. So when tumors adopt a fermentation pathway, I do not know if it is causal or consequential or permissive to the cancer, but it happens because, as I mentioned before, they grow in hypoxic conditions.
Yep.
So so therefore, it makes my original idea a little bit more relevant, meaning that you try to address the tumor from the metabolic aspect, not try to explain the tumor from the metabolic aspect. Let's suppose that the tumor is a terrorist organization, okay?
Yeah.
Does it really matter if someone tries to find out how did it evolve? And no, what really matters is cut the funding of the terrorist organization and it will dismantle. Okay, so to trying to find the origin of it, I think is the wrong question. It's an important question, but not the most important question. What you would like to do is to see this node of evil disappear. Okay, so you cut the funding. The same with the cancer. You cut the fuel, as Professor Seyfried used to say. Okay, so the fuel the tumor uses is very different from the healthy tissues, and there is a vulnerability. There is the opportunity.
Yeah. Have you been involved with the latest paper that's under review at the moment?
Which paper?
Press Pulse for glioblastoma.
Oh, I don't remember. With Professor Schaefer's press pulse therapy.
Yeah, well, no, there's a paper been written. Thomas Durage is the primary, the first name on the paper, but apparently it's 110 pages long.
Okay. The metabolic management of microenvironment acid in glioblastoma.
Is that what it's called? You've just revealed something now.
Because no, it's not this one. It's another one. No, so I'm not involved in the Durage paper.
Right. Okay. It's 110 pages long, and it's talking about the press pulse for managing glioblastoma, and it's under review at the moment. And I've been waiting for it coming out of review for months and months, and we've still not heard anything.
Well, yeah,
so
it's 110 pages, so I can imagine that nobody wants to review it. Or it will take some time.
yeah. Is that the situation with papers?
Absolutely.
People are not paid to review. They
Yeah, I wouldn't say it's the general scheme, but yes, people review things for free, and some do it because they want to, some do it because they want to take revenge, some do it because they want to put it into their CV. So there are many different ways for reviewing a paper. Or some do it because they want to suggest to the authors to cite them into their revised manuscript. So there are many reasons. I mean, I wouldn't say that there is a one particular reason that fits them all, but you can have your paper reviewed by people with less than perfect agendas, let's say. But what you can imagine is that when you have a very long or a very difficult paper to review, then it can be pushed to the extremes of either rejecting it because they simply don't understand it or it's too long, or accepting because they don't give a damn, and they say, okay, if it is a low impact factor, they can say, okay, that's probably okay, and they can get accepted, which means that is actually very very bad for the manuscript, because if it contains fundamental errors and then it gets accepted, I mean, it could be bettered by removing these errors, but they were not caught during the review process. So imagine that it gets accepted and then there are fundamental errors, and then it gets published online, and that means forever. And then people read it and they see the errors and they say, "Oh, that guy is just publishing bullshit," and then he's red flagged.
Yeah. So right, that's a really good insight into the whole process. Something that obviously I've not considered. So, what advice would you give to Jason Watson that's in his state now?
Well, what I would do if I were him is that I would go to clinicaltrials.gov or wherever he lives. Is he a UK resident or US resident?
He's actually in Canada.
In Canada. Well, I'm sure they have their own clinical trials there, or maybe they can move to the United States and put up his condition, which clinical trials accept people with such a condition, and then try to find anything that is from the metabolic aspect, because I'm sure there are clinical trials for many cancers, maybe hundreds of them, but only very few will be addressed with metabolic inhibitors, and try to see if they can take him through such a clinical trial, because that's the only way to get out of the standard of care, because the standard of care is something with, unfortunately, an expiration date.
Right. Yeah. Here in the UK, we don't have a right to try. In America, you have a right to try, but by the time you've actually done the whole right to try, you're dead anyway.
Yes. Is it NHS what you are talking about, or anything in the UK?
In the UK, we don't have the right to try. We've got the NHS, And when you think about the amount of money that is spent on by the NHS on cancer treatments that are not effective, it's all from our tax pounds. I was going to say dollars then, because we do have a large audience in the US, but it's from our tax pounds, and it's an absolute travesty, the fact that we're spending so much money on cancer treatments that don't work. And the greatest charity here in the UK, Cancer Research UK, 400 and something million pounds they get in funding and are researching what? Genes and gene therapies, and it's like I do troll them on Twitter, and when they put a post out, I give them shit basically.
I've tried a couple of times their grant opportunities, but I got rejected outright. So they're very much gene oriented.
Yeah, which really it's a sad state of affairs. Well, Christos, it's been absolutely amazing talking to you. Is there anything you want to say to the audience?
Well, for those who have the power to advocate, please pursue. Advocate on behalf of the metabolic aspect of beating cancer as much as you can.
Yeah, I mean, when I see people like Stephen Bartlett, the guy who's a multi-millionaire, who just interviewed Professor Seyfried on his channel with 7 million followers or 7 million subscribers or whatever, I just want to say to him, what are you doing now? Because Professor Seyfried says that this is the greatest, it will be known as the greatest tragedy in medical history when we look back, from a retrospective viewpoint. But I don't agree with him. I think this is the greatest tragedy in human history, not just in medical history, in human history. Viewing cancer as a purely genetic disease is well, and when I see people like, why are you not dedicating the rest of your life to getting that word further out there? Because, like I say, he's a multi-millionaire businessman. He was on Dragon's Den as a dragon here in the UK, with thousands of investments in various different companies. A sort of Richard Branson, Elon Musk type of guy, but obviously to a much lesser level than Elon. And I have tried reaching out to Elon. I've even wrote him actual physical letters, and the same to his brother, who owns a restaurant in Boulder, Colorado. But it's fallen on deaf ears, and unless May suddenly develops a tumour of some description, I don't think he's too busy landing rockets and building cyber cabs. Okay. So yes, great to talk to you. We'll have to schedule something with the professor at the same time.
Okay, we can do that, absolutely.
Okay. Christos, brilliant. Thank you for being here today.
Thank you.
Thank you. Bye.